Alright, so today we're going to be talking about arithmetic sequences in series, and we're going to be talking about being able to find the first term and the common difference in a arithmetic sequence, and solving problems involving the nth term, and then finding partial sums. So taking a arithmetic series and finding the sum for a certain number of terms. Before we begin, though, we would need to know what exactly an arithmetic sequence is. And an arithmetic sequence is a sequence of numbers where the difference between consecutive terms is the exact same. So what else that would mean if the difference is the same? Basically, we're adding the exact same thing from previous terms to get to the next term. So we're difference meaning that we are adding the same thing. So what does that look like? In this particular sequence here, we have 6, 9, 12, and 15. So we are being asked to identify the first term and the common difference. So clearly we see here that the first term in this sequence is 6. So our first term is 6. And then the common difference, we go from 6 to 9, we're adding 3. 9 to 12, we're adding 3. And 12 to 15, we're adding 3. So we do have an arithmetic sequence, and the difference, the common difference in this particular problem is 3. And then as we move on to the next one, similar type problem here, we have our first term is 42. And then what are we adding to get to the very next term? We're adding a negative 3, a negative 3, and a negative 3. So in this particular case, our common difference is negative 3 to get to the next term. Then our very last one, go ahead and take a minute, try to solve for C. And as we can see here, the first term is 1 in this particular case, and the difference, we are adding 1/3 to get to each of the following terms. And then what we have down here is the formula that we're going to be using in order to find the nth term. So so far we've found the first term, and we have found the difference. But now if it asks to find the, say, 10th term, we could plug in the number 10 here in order to find the 10th term. So this is the formula we can use to find any random number in the arithmetic sequence. So doing that, we need to find the 21st term here. So first off, let's make sure that we have the formula written down so that we can remember this. Times the difference. And I actually like to write the difference in front. And so some of the things that we need to find first. We first need to find the first term, which we see here is 4 in this sequence. And then what is our common difference? As we go from 4 to 9 and 9 to 14, we are adding 5 every single time. So now we can plug in to find the 21st term by plugging in 21 for our n's, because that's the numbered term we are looking for. We'll plug in 4 for our first term, plus the common difference of 5 times 21 minus 1. And why we are multiplying there is because that common difference is being used 20 times to get to that number. So we have 4 plus 100, telling us that the 21st term, right here, the 21st term is 104. Now we could solve that problem, solving for something completely different, by solving for the nth term. And in this case, it's telling us that the nth term is 702. It has the value of 702, but we don't know what numbered term that is. So in this case, we need to be solving for the n value. And then as we look in our sequence, we can see that the first term is 2. And then what are we doing to get to each term? We go from 2 to 9, 9 to 16, so we have a common difference of 7. So we can plug all of this into our formula that we have. It tells us that our ending term is 702. It tells us that our first term is 2. And we have found that our difference is 7, but we don't know our n minus 1. So go ahead and pause the video and solve for n in order to find what numbered term it is. So when we finish solving for n here, we get 101, which tells us that the value of 702 is our 101st term in this sequence. Now when we move on to this other one, if we read the problem here, the second term of an arithmetic sequence is 11, and the 10th term is 35. So we aren't given the first term here, so we need to actually work a little bit backwards in order to construct this sequence. We're given the second term of 11, and we're given the 10th term of 35. And if we look at our formula, we actually don't always need to have the first term. If we notice here, that 1 and that 1 are the same. So we could actually use this with the second term like we have here. So we have the 10th term right here, which means that our n value is going to be 10. But then what we also have here is that the second term is 11. So we'll put 11 here instead of it being the first term, which means that this 1 is now going to turn into a 2 because it's the second term. And we could actually solve to find the common difference in this case. And find out that our difference is 3, which allows us to construct the sequence, because if our second term is 11, we could then go backwards to get 8. And then know that we add 3 in each particular case to construct this sequence. And the 10th term would equal 35, matching what we were given. The last particular problem that we're going to be solving is finding the sum. And this tells us how to find the sum of an arithmetic sequence depending on the number of terms that we are looking for, and then we just need the first term and the last term in the sequence up to where we are solving for. So in this problem, finding the sum of this arithmetic sequence, let's first write down our two formulas that we have. Second one is finding the term in an arithmetic sequence. So what this tells us here is we're finding the sum of the first 20 terms. So that 20 tells us that we have the 20 there for number of terms. We're finding the sum of the first 20 terms in this sequence, and 20 is our n value. But then we need to find the first term and find the nth term in this sequence. Well, and the nth term then is the 20th term, because it says we're using up to the 20th term, so these n values have to match everywhere. So then now we need to find the first term, so plugging in 1 here, so 3 times 1 plus 1 gives us a first term of 4. And then we will need to find the 20th term in the sequence here. So plugging in 24n. So 3 times 20 plus 1. And we get that that term is 61. And so when we add this together, we're going to do 10 times 65. And telling us the sum of the first 20 terms of this particular sequence is 650. And that concludes the notes for the arithmetic series.